In this video, I'm going to cover Chapter 2, Measures of Distribution. Um, so I just combined the lecture note, Chapter 2, my lecture note with the PowerPoint lecture slide. So before I jump into the Chapter 2, let me review what we did in the last time. So last time I covered Chapter 1. We so a bunch of the definitions and um, the the terminologies, definition of terminologies. So the statistic, I didn't cover the some basic definitions of terminologies. The, so let me go over them first. So statistic, uh, definition of statistic is the science of planning, studies, and experiment. So obtaining data and then organizing, summarizing, or presenting, analyzing, and interpreting those data and then drawing conclusion based on them. So this, the organizing, summarizing, and then presenting by the drawing table, the the figure, for example, histogram or the bar graph or pie chart or making tables. Um, these are called the descriptive statistics. That's what we're going to do, chapter 2. And then the approximating mean or average population or the concluding the hypothesis based on the data, sampling data. These are called the inferential statistics. And then data is the collection of observations, such as measurement, gender, or survey responses. And then population, population, right? Population is the complete collection of all measurement or data that are being considered. The census is the collection of data from every member of the population. And the sample is sub-collection or subset of members selected from population. So now the next one, I didn't cover the statistical and the critical thinking in the chapter 1, but so let me go over briefly. So the process um, of the statistic is this. First, we need to collect the sample data, right? So to collect the sample data, we got to use a sampling method. So we study a whole bunch of a lot of sampling method, right? The random or systematic, and then the stratified or clusters, okay, things like that. So, and then once we once we collect the sample data fairly, then we analyze using discrete statistic or inferential statistics. So that's what we're going to do in rest of chapters. In chapter 2, we're going to study about the discrete statistics, and then the rest of from chapter 3, we're going to study inferential statistics. Anyway, so and then now once we analyze the data, and then we need and then we're going to conclude uh, about the treatment or some the you know the way to find something based on the sample data. So there would we study two things: practical significance and then statistical significance. So statistical significance means this: the when we get a result in a study that is very unlikely to occur by chance, then we say that that's statistical significance. So, and the practical significance is even though even if some treatment or finding is effective, it turns out the effective based on the sample data, but but common sense, uh, they might just suggest that the treatment or finding does not make enough of difference to justify it, the U is used or to be practical. So that we say that we conclude that that's the practical significance. So the normally if the difference between before treatment or and then after treatment, the difference between the data is less than 5%, we say that that's the statistical significance. Okay, so um, that's what we did in chapter 1, and then let's jump into chapter 2, some measures of distribution. So first one, we're going to start from the frequency distribution. So what's a frequency distribution? There's nothing but um, the table showing the pro excuse me, the showing the classes and then the number of the data belong to each classes. So what's a class? So let's see. Let's jump into let's see you know the um, PowerPoint slide. So frequency distribution here to show how data are partitioned among several categories. So our classes by listing the categories along with the number or frequency of data values in each of them. So the class consists of the this lower class limit, upper class limit. So actually class is a range of data. And then let me see. So you see, give me a second. Yeah, so look at this table right here. So in the example, so McDonald lunch service times. So see in the table right here, time, second, the frequency. The first column is showing the frequencies classes, right? So 75 to 124, 125 to 174. So you see the range of the data. The then the 75 in this example, 75 is called the lower class limit, 124 is upper class limit. So back to the slide here. So the lower class limit, the smallest numbers that can belong each of the different classes. The upper class limit is the largest numbers that can belong to each of the different classes. So what about class boundary? The numbers used to separate the class, but without the gap created by class limit. So normally class limit is in this case the middle number between the upper class limit and then the lower class limit in the next class. For example, the 124 and then 125. The the boundary see here, class boundary is gonna be for between the two classes gonna be 124.5. And then the class boundary between second and third classes should be 174.5 because it's a middle number between 174 and 175 going to be 174.5. So this is you see that. And definition is this: class midpoint. The value in the middle of the classes, each class midpoint, can be found by adding the lower class limit and then upper class limit and dividing the sum by 2. So literally, the class midpoint is just midpoint between the lower class and the upper class. Okay. So and then class width is it's kind of the length between the lower class and the upper class. The difference between two consecutive lower class limit in frequency distribution. Or yeah, you can calculate find the class width like that way. So for here, so class width gonna be for the between the first and second class in this example. I think let me zoom in. Yeah, so in this slide table right here, so 125 minus 75, that's going to be class width for between the first and second. But normally the class width what class width is fixed, which means that the first, and second, third, fourth, and fourth, fifth in this example, every two every pairs of the classes, consecutive the classes, the class width must be same. So now we see, okay. So now see, okay, procedure for, see next slide, procedure for constructing a frequency distribution. So we select the number of classes, usually between 5 and 20. But yeah, sometimes problems give you the number of classes. Okay, so and then ask you to plot the make a frequency distribution. Okay, then you don't have to then select the number of classes. Okay, because normal usually the problems the number of classes is given. Okay, and then now and then we calculate class width. So then we do this maximum data minus minimum data value divided by number of classes, and then round this result to get the convenient number. It's usually best to round them. So I know it's kind of it's hard to understand this step. So let's see example. Okay, so now let's see right here. Okay, look at this. Let me explain the how to make a frequency distribution from this example. Okay, using McDonald's lunch service times in the first table. Follow the procedure shown on the next slide to construct the frequency distribution shown in the second table. Use 5 classes. So yeah, they just explain about this step here. So now see, first one, see the use 5 classes. So number of classes given, right? I told you. So now then step one, see, select the 5 as a number of desired classes. Yeah, because the problem says that. So now then calculate the class width as shown below. So class width is going to be maximum data value. You're going to find a maximum data value. So in the, you see that here, the data table right here. So we find maximum um, data value. So which is the think 300, see, yeah, 308, right? 308. And the minimum data value must be 83. And then divide by 5, which is 45. Okay. And then we round up to a more convenient number to 50. So um, it totally depends on problem. Sometimes you don't have to round up. Okay. But normally we got the 50, 45. I mean, the first digit is greater than or equals 5, you better off rounding up. Okay. And then step 3, then what minimum data value is 83, which is not a very convenient starting point. And so go to the value below of 83 and select the more convenient value of 75 as the first lower class limit. So you may just start from the 70, okay? But let's start with 75, okay? So 80, I'm sorry, you may just select the 80, okay? But let's start with the 75. Okay, so right here 75, and then we add what? Class width. Well, we got 50 as class width, right? So we add a 50 into 75. That's going to be 125. Then we subtract 1, okay? Because 125 must be the what? Lower limit of next class, okay? So now doing this, okay? And then we're going to find out the what? The the number of data belong to each classes, okay? So see, there is other way to make a frequency table easier than that. So in this case, the number of data in a data is 50, so not quite big, but it's kind of um, a little bit is, it's hard to figure out number of frequency for each classes, right? So let me use so we the other way to figure out number of frequencies, um, is to use the calculator. So we plot the histogram using calculator and then figure out the so that we can figure out the number of frequencies for each class. So then that must be easier than just counting, uh, the data belong to each class manually. So let me uh, so let's see. Let me just plot the histogram of this data and then figure out the frequency for each class. All right, so I'm gonna, as I announced before, I'm gonna use TI-84 plus calculator. So if you have TI-84 or 83, I think if you have, if you use TI-84, that's gonna be really similar to the TI-84 plus. But if you have TI-83, then don't worry about that. So the instruction how to use calculator should be in the in, the instruction video should be in the Blackboard. So now, so first one, we need to enter data, right? So to enter data, you just press stack, the button right there. Okay. Then you see the edit. There are three tabs. Or see that the edit, and then the calculate, and then the test. So we just click the edit. Okay. So just click edit. Then you see you see L1 through the L3 and 4 and 5. You can make more column. So you see the whole bunch of columns. So I just already entered the data into the column L1. Okay. So then for each first you enter the first data in the first row, and then move to the next row, and then enter the second data. And doing this, so I entered all the data into L1. So there are 50 data values. So let me double check. So it's 50 data right there. So now, and then we go to the stack plot. You see the stack plot right there. So then we press second button and then press Y equals to go to the stack plot. And then here you have to make sure that there are three plot 1, 2, 3 right there. So make sure that plot 2 and plot 3 is off. So how can you turn off the plot 2 and 3? Just go to the plot 1, just enter, and then there's 3 tab right there. So plot 1, plot 2, plot 3. So go to the plot 2, press enter, and then off, and then plot 3 is off. Okay, and then we back to the plot 1. So now make sure that you turn on the plot 1, and then we select the one of the type, which we should choose the histogram, right? So this is the polygonal frequency gravity, and then this is this box plot. Okay, so and this is rate to the regression plot. But anyway, so we choose histogram right here, and then X list. We put the name of the column what you enter the data. Okay, so for me, I enter the data into L1, right? So here. What about L2? Then you just delete, clear. Okay, and then you see that right here, L2 right there. So we press second, and then press number 2, the L2. If you put the data into the column L2. But for me, I was put L1, so second L1. And then leave the frequency as number 1, okay? And then next, press zoom, okay? Zoom. For this calculator, for my calculator, it's somewhat different. So the if you get the same situation as me, just enter zoom, press zoom, and then you got the kind of the options just just pop up. Then back to the stack plot, okay, and then just press zoom, okay. and then press number 9. So what's the number 9? Number 9 is the jump start. Press number 9. Okay. So now then you see that this is a histogram. Histogram is you see the this is a histogram, and they're showing that the frequency, and then the classes as the vertical bar. So here we got the 1, 2, 3, 4, and the 5, 6, 7, 8 vertical bars. So in the calculator, automatically calculate the number of classes and then the class width. Okay, but we wanna we wanna plot the histogram having the exact same class width and the number of classes in the textbook, example what we just saw, right? 5 uh, the classes, and the class width should be 50, right? So to change those parameters, we press the window. See, by the way, before doing that, then how can you figure out I mean, so in each vertical bar, the height of bar represent the frequency, and that first class, and the second vertical bar, the height of the bar represent the frequency, second frequency. So how can you figure out, how can you just see, how can we see the class, the lower class limit, upper class limit, and the frequency in that histogram? Just press trace. You see the trace right here, trace. Then you see that point showing the what lower class limit in the first vertical bar. Lower class limit is 83, and the upper class limit is approximately 155, and then the number of data belong to that class is 7. See, lower class lower the letter n is the 7. N means the number of data belong to that this class, so 7 right here. And then moving next one, showing the lower class limit, upper class limit, and then frequency, right? Like this. Anyway, so we want to change the what class, the limit, I mean number of classes and class width, right? So we press window. Okay, x minute, that's the lower class limit of first class, so it should be 75, right? And the x maximum, that means upper class limit of the last class. Okay, it should be 325, right? Okay, I know in the frequency table it was 324, but in calculator just we entered 325. Okay, the x scale, that's the class width, which is 50. So we got 50, right, in the textbook in the example. And the y minimum, just you can leave it. Okay, y maximum is the maximum maximum frequency in a class. So since the total number of I mean the number of data is about 50, right? So normally we put the 50. We put the total number of data. Okay, and then don't press zoom. Okay, once you're done, okay, and then press graph. Okay, so now how many vertical bar we there? 1, 2, 3, 4, 5. Yes, yeah. It means that this histogram is a graph of the frequency table having the 5 classes. And then since we set the class width as 50, so the height of the each vertical bar represent the frequency of the frequency table what we saw in the textbook, okay, in the slide, in lecture slide. So then we just press trace, see here, and then the lower class limit is 55, upper class limit is less than 124, so we can say 120 less than 125, so we can say that 124, right? And then see that frequency 11, then 24 right here, and then 10, and the 3 and 2. This is exactly the same as the frequency table in the example McDonald's lunch service. So We see, let's see these examples in the handout, okay, lecture note handout. So the data, the represent the airplane taxi out time. So time minute to taxi from the terminal to the runway for a sample of departure at JFK Airport in New York. So construct a frequency distribution table with a lower class limit of 10 and class width of 5. So these problems, yeah, so luckily, these problems give you the specific a number for class width and lower class limit. So you don't have to figure out class width. You don't have to round up or round down, okay, the lower class limit. Okay. So since the yeah, you can do let me just draw the frequency table first, and then let me use a calculator to figure out uh, the number of the frequency for each class. You can do by hand. Okay. So in the table, in the data, we gotta find out the what minimum data value first. Okay. So oh, I'm sorry. So since lower class limit, uh, the problems says that what the we gotta set the lower class limit as 10, right? So we start from 10. Sorry. So here's a class and the frequency. So this is 10. Okay. Since lower class width is 5, so the next class lower class limit must be 15, right? And then okay, and then 20, then 25, right? So now see, since in the data, so maximum data value is at 49. So we just keep going, 30, then 35, okay, and then 40, and then 45. Okay, so 10 through the 14, and then 19. You just keep adding keep adding 5 into the previous upper class limit to figure out the upper class limit of current class. It's 24, okay, and then 29, okay, and then 34, and then 39, okay, and then 44, and then 49, right? So since 49 is the maximum data value, so we stop here. Okay, the problem doesn't mention about the number of classes. So you don't have to consider a number of classes. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. We got 8 classes, and the class width is 5. The lower class limit is 10. So now then we find out the frequency for each classes. Okay, so then you can do by hand. Okay, or you can use a calculator. What I did for figuring out frequency in the previous example. Okay, so then for me, that's the think let me give me a second. Yeah, so I got these numbers as frequency of each classes, so you can check that. You can do by yourself. Okay, so in this case, so from the frequency distribution table, we can see that how the data are spread out. So okay, so what's the I mean, where the most of data um, is located. I mean, So it can in this data. So see the second free class. So most of the data is in the second class. So we can see that then the uh, the statistically, the most of data is, since most of data is in between uh, first class to the third class, so especially second class. So then it's gonna take statistically it's gonna take 8 minutes, 10 minutes through the 24 minutes. Okay, we can say that. So now let's see the other type of frequency distribution. So the other this see that here, the relative frequency distribution. Yeah, that's the similar to the frequency distribution, but we're gonna calculate the relative frequency instead of frequency, just frequency. So relative frequency is calculated by frequency for a class divided by sum of all frequencies. Okay, and the percentage for a class. Sometimes the frequency table shows the percentage for a class that is calculated as um, the relative frequency multiplied by 100%. Okay, so in this example, the relative frequency, let's figure out the relative frequency. So for the relative frequency, we need to figure out the total number of data value, which is 20. So in this case, the relative frequency going to be 4, which is frequency of the class divided by total number of classes, a total number of frequencies, which is 4 over 20. I'm sorry, 20. This is 8 over 20. So 4 over 20, then 1 over 20, then 2 over 20, and then 0 over 20 is 0, right? 0, and then 1 over 20. Okay. And then percentage is just multiply each number, relative frequency by 100. That's going to be percentage, okay? And then cumulative frequency, we see frequency is the for each class is the sum of the frequencies for that class and all previous classes. So in this case, for the first class, cumulative frequency is going to be 4. And then next class, the cumulative frequency is going to be not just 8, but 8 plus all of the frequencies in the previous classes. So which is 8 plus 4, which is 12. Okay. And then 4, not just 4, 4 plus 8 plus 4, which is 16. Okay. Then 17, right? And then 19. And then 0, 19, sorry, 19, and then 20. So in the cumulative frequency, keep in mind is in a cumulative frequency of the last class must be equal to what? Total number of data value. Okay. And then so okay, now the now back to the lecture note right here. So histogram, we saw the histogram, right? So a graph consisting of bar equal width drawn adjacent to each other. So horizontal scale represent the classes of quantitative data values, and then the vertical scale represent the frequencies. So height of the bar correspond to frequency value. Yeah. So through the histogram, we can figure out the distribution of data, okay, and then center of the data, and then spread of data, and the outliers too. Okay. So do you know the outlier? Right? It's explained in chapter 1. Outlier is the data value which is really far away from the most of data. Okay. So and then this is the instruction how to plot the histogram. I just show you, right? So it's just here. See that? And then this is the other type of graph. So dot plots. Okay. So the other one is dot plot. So dot plot um, used to plot the quantitative data, in which each data value is plotted as point or dot above on a scale of values. So dot represent equal values are stacked. So let's see. So here we can't plot the graph dot plot using calculator, so you have to by hand. Okay, so let's see examples for the dot plot. Not here. Okay, that's fine. So we back to the that examples. Okay, here. So let me plot the dot plot in this data. Okay. So in this data, so first we draw the horizontal line, represent the class. Okay. So it's a 10. Okay, and then 20, and a 30, and then 40, and a 50. Okay. So now then let's see the data is first one we see 30 right here. So for each we just data, we plot the dot first corresponding to each data value. Okay, so we got 30, and then next data is 19. 19 is right here. 19, and then 12. So it's a 12 right here. And then 19 again. So 19. And then 18. 18. And then 22. Here. And then 31. It should be right here. 31. And then 13. Right here. Okay, and then 14. Here. 15. Here. The 49. Right here. So doing this. Okay. So then you see that the what you can see that the data is going to be stacked, right? So that we can see which data distribution of data and how data is spread out. Okay, so that's a dot plot, and then let's see the feature of the dot plot. Display the shape of distribution of data. Yes, right. And it is usually possible to recreate the original list of data values. So the normally the data is the data values. I mean, are the sorted, randomly. So using by plotting the dot plot, we can figure out the the low value of data, and then you know the large value of data. We can figure out that. So now the stem plot. The stem plot is the represent, you see, that quantitative data by separating each value into two parts. The stem means the leftmost digit, and the leaf is the rightmost digit. Okay, so this in the example, this represent the figure above display the pulse rate of the male in the data set one body data in appendix B. That data is in the blackboard. So then the lowest pulse rate is 40. So you see the 4, 5, 6, 7, 8 through the 10 right here. This that number represent 10 digit of the pulse rate, and then 0 and 2 and all numbers on the right side represent the ones digit. Okay, so the 4 and then 0, 2 means the 40 and 42, and then so you see the 9, and then the 0, 2, 4, 6 that represent the 90, 92, 94, 96, 96 pulse rates. Okay, so now you how to read, how to read stem plot, right? So a feature of stem plot to show the shape of the distribution of data, yes, and then retain the original data value. Yeah, and the sample data are sorted or in order. Yeah, so the for the stem plot, the data will be sorted. Okay. So now then, time series graph. So graph of time series data, which are quantitative data that have been collected at different point in time, such as monthly or yearly. So if data is collected by time, then we can plot the time series graph. So that we can, from the time series graph, we can see that how the data is changes over time. Okay. So now constant plot dot plot. So I plot the dot plot, right? And then let me skip the drawing stamp plot. Okay. So now the common distribution. So the when you plot the histogram, or the dot plot, stamp plot, then through the graph we can figure out the distribution of the data, right? So now we see for um, the common or popular distributions normally occur in most of the data. The first one is this normal distribution. This is really important, and then we can uh, deeply study this one later. Okay, so bell shape is normal distribution has a bell shape like this, and then most of data is around the center of the class. Okay, and then um, the data is we're gonna have less data as the class is decrease or increase. Okay, and then the next one is the uniform distribution. So uniform distribution, as you can see that for each class, the frequencies are the almost equal. Okay, so the example of the uniform distribution is winning lower numbers. That makes sense, right? And then what about the example of the normal distribution, IQ score? Okay, and then skewed right is the most of data is not center but the less than center, and then we this distribution has a kind of long tail on the right hand side. Okay, it's called skewed right. So annual the example is annual income. Okay, yeah, makes sense, right? And then the skewed left is the has the long tail on the left hand side, because it means that most of data is on the class which is bigger than center. Okay. All right. So now the bar graph. So I mean, so these the stamp plot, and then the dot plot, and then histograms. These are just a graph of the numerical data value. But what about the the graphing a graph of the qualitative data? So data value is not numerical. Maybe the categorical, is low, medium, high, or man, male and female, or blue or yellow, something like this. So now then, one of them is a bar graph. It's similar to the see, where's one? Not here. Yeah, similar to the histogram, but for each the what the bar uh each bar, and I mean the width of bar doesn't represent class, but just the the label of the categorical data value. Okay, so graph of bars of equal width to show frequencies of categories of categorical the qualitative data. Yeah, so vertical in the bar graph of the vertical, I mean the height of the bar represents frequency of the categorical data value. Okay, and the width that doesn't represent the class. Okay, low limit class, upper limit, that there is no such a the values. Okay, so and then each bar is separated. Could be you see the bar may or may not be separated by a small gap. Okay, so from the feature bar graph show the second. So to show the relative distribution of category data so that it's easier to compare the different categories. Now pie chart. So it's very common, yes, graph that depicts categorical data as slices of circle, which size of each slice is proportion to the frequency count for the category. So this example of pie chart. So we use a lot for the qualitative data. So the each the category is represented by the portion of the circle. Okay, that normally represent the percentage of uh, out of the total number of frequencies. Okay, and then frequency polygon. Yeah, this is a frequency polygon right here. So now, so excuse me. So frequency polygon, we just instead of drawing the similar to histogram, but instead of drawing the vertical bar, we just plot the dot for each the okay say for each class, the middle of class. Okay, class middle of class. So we're in 49.5. That normally class middle of the class, first class, and then 99.5. That's the second the middle of second class, and then middle of third class, and then we just plot the dot and then connect the with the line segment. That's going to frequency polygon, and the relative frequency polygon. Instead of the counting the frequency, we can find the relative frequency. So first we draw the relative frequency table, and then find out the middle of the class, and then plot that middle of classes dot as dot, and then connect the line segment. Okay, so now then so see the now next one, examples. IQ score, let's see example right here. So constructive frequency distribution, IQ score data of IQ score is given, and the constructive frequency distribution table with the lower limit of 50 and class width 20. Then draw a relative frequency histogram and frequency polygon, and then what is the approximate shape of the distribution. So let's plot the frequency polygon. To do that, let me we need to figure out the what frequency table, right? So let me figure out. So let me plot make a frequency table first, and then I'm gonna plot the frequency polygon using the frequency table. Okay. Also, I'm gonna plot the frequency histogram too. Okay. I mean relative frequency histogram too. Okay. So yeah, I already entered the IQ score data into L2 column L2. As you can see that. Okay, so to go press that, and then go to the end. You see the edit right here. Press enter, and then the I just enter the all the data value, IQ score data value in column L2. Okay, so now so let me plot the histogram. Okay, so the now go to the stack plot. Okay, press second, and then press Y equals the button to go to stack plot, and then I'm gonna use plot one, and then select the histogram as a type. Then instead of L2, it should be L. Instead of L1, we put the L2, right? So press second and L2, number two. Okay, and then press zoom. I told you some the TI you know for TI some TI 84 plus got this kind of situation, including me. So in this case, don't be frustrated. So we press second, and then y equals, go to the stack plot again, and then press zoom again. Okay, then press 9. So we got this. But the problem says that what? Construct a frequency distribution table with a lower limit of 50 and class width of 20, right? So we have to set that those parameters to get the right histogram what the problem is asking. So we go to the window, okay, and then x minimum, that's going to be lower class limit of the first class, should be 50. Okay, and then maximum, so let's see, to let me calculate. So in the table, let me draw a table right here. So starting from 50, then class width 20, so it should be 70, and then 90, right? Then 110, and then 130, right? Then 150. See, so see here, in the maximum data value is 120, 140, 141, right? So we don't need that class, so we just get deleted. Okay, and then 50 to 69, and then 89, and then 109, right? And then 129, and then uh what 149, right? 149. Okay, so maximum the what the upper class of the last class must be 150 in calculator, so 150. Okay, the x scale, x as the CL means x scale, that's class width, which is 20. Okay, and then y maximum, yeah, so you can put the 20 or 10, 20, okay, which is the total number of data values. Okay, x minimum x value, you don't have to change it. Okay, and then press graph. Don't, I told you don't put the zoom. Okay, press graph. Okay, so now then press trace to figure out the frequency for each class. That was the first one is 2 frequency class. There's a 2. Next one is 4, and then 9, and 3, and 1. Okay, now we figure out, let's just figure out the total number of frequencies to if that is right. So 2 plus 4 is 6, and the 15. Let's see. Yeah, so we got the 19, right? So give me a second. Yeah, I just I didn't put one more data. I missed the one data value in the the column L2. Okay, so yeah, I just add one more data value. Okay, I missed the one data value in L2, so I did again plot the histogram again. So it's not 5, it's 4, it should be 5. Okay, so 2 and 5 and 9 and 3 and 1. Okay, I'm sorry about that. All right, so now we got the frequency table, and then I got the frequency histogram. But the problem says that draw a relative frequency histogram, right? So then so there is we can't plot the frequency relative frequency histogram using calculator. So to plot it, you have to do by hand. Okay, so here first we need to figure out the relative frequency, right? So the relative frequency, okay, which is 2 over 20, and then 5 over 20, and then 9 over 20, and then 3 over 20, and then 1 over 20, right? Okay, let me skip the plot drawing the relative frequency histogram by hand. Okay, so now frequency polygon is this right here. Okay, so let's see, we're gonna find the middle of classes, right? So which is the that's gonna be, let me see, let me find the middle of classes for each. Okay, all right, so I got the class midpoint for each classes, 95.5, 79.5 through the 139.5. So, and then the vertical line axis represent frequency. Okay, so to put for the 95.5 the frequency is 2, right? So we put 2. Let's say here's a 5, and then here's a 10. Okay, 2 maybe right here, and then 5, then 9, and then 3, and then 1. Okay, and then we just connect the each dot by the line segment like this. Okay, that's a frequency polygon. Okay. Anyway, so we can see that through the histogram, either histogram or the frequency polygon, we can see that uh, data is a normal distribution, right? Okay. So now next one is about the give me a second. We're gonna talk about the graph that deceive. Okay. So the first one is a non-zero vertical axis. Second one, pictograph. So sometimes when you look at the newspaper or article and then showing the the graph of data, maybe just that graph doesn't represent the data correctly, fairly. Okay, to deceive customers or readers. Okay, so for one of them is a non-zero vertical axis. A common deceptive graph involves the using a vertical scale that start some value greater than zero to exaggerate differences between groups. So we see example right here. In that graph, see showing the fuel efficiency for three cars, comparing fuel efficiency, comparing three cars. Okay, Honda Civic and then the Chevy Aveo and Toyota Camry. Then look at the vertical line. The vertical line represents the fuel consumptions, highway fuel consumption. Doesn't start from the zero. Okay, you make if you just the correct vertical axis starting from zero, we're gonna get this right graph on the right hand side. So in the Honda and the three cars, the fuel economy doesn't pretty much big difference. Doesn't have a big difference, right? So this is one of the example of exaggerating difference um, uh, data values. Okay, result. And then pictograph is this. Drawing of object called the pictograph are often misleading. Data that are one-dimensional in a nature, such as the budget amount, are often depicted with two-dimensional object, such as dollar bill, or three-dimensional objects such as stacks or coin, arms, and better. We'll see. So example, let me see. So let's see. Now example is this. You see, that one represent the the tuition fee uh needed to graduate. Okay, for each grade, for each school. Okay, I mean, I'm sorry. The average income of the average income of people don't has advanced degree or bachelor degree up to high school diploma or low high school diploma. Okay, so now then you see when you look at this the cube, so it looks like the people I mean the people having the advanced degree is much, I mean, more than three times the income is more than three times the people income don't have high school diploma. But when you look at number here, so this is 18, um, the 734, and then this is 74,602. It's just three times difference, right? This 74.604 is a three times greater than the 18.734. But when you look at the cube here, that cube is much the the volume of that cube is much bigger than that cube, more than three times. So this is one of the exaggerating or misleading. So they depict one-dimensional data with three-dimensional boxes. The last box is 24 times as larger as the first box, but income is only four times as large. Yeah. So next one is this. Yeah. So when you look at this graph, so it's what the that the design of, you see the dollar, the graphic in the bar really, the obscure the people when they read the height of the bar. Okay, so that's the one of the example of the graph pictograph to save the data. Okay, so let's see. Now next one. Yeah, so here concluding our thought. So in the visual display of the quantitative information, the Edward Tuffet offered this principle. For small data set of 20 values or fewer, use a table instead of graph. And the graph of data should make us focus on the true nature of data, not on other elements such as eye-catching but distracting design feature like this. Okay, so now so that people easily figure out the distribution of data. Okay, do not distort the data. Construct a graph to reveal the true nature of data. Don't starting from you should start from the zero axis. Okay, and then almost all of the ink in a graph should be used for the data, not for other design element. Yeah, that you can figure out that. Okay, so that's for the I just covered chapter 2. Okay, the next time I'm gonna cover chapter 3.